So again, we can see the functionality here. Why are we getting an error? Okay, so in any case, let's dive straight into the functionality of, let's just have a look at this again. So white plays first. Oh, I'm having a bunch of errors. Okay, so before that, we will just have a look at the functionality of the queen. So the way that this is going to work is we can simply go and say the functionality of a queen would be exactly as it is for a rook. So we can simply go and copy all the functionality that we have already implemented for the rook, and then we can have a look at the functionality of a bishop, and it should be exactly with all the functionality as a bishop. So this should be able to do that, but then also do this. So again, yeah, we should just be able to do this, add in all of those items, and then once we implement this, we should now be able to do all the available moves. So because a queen itself is both a bishop and a rook put together in terms of functionality. Okay, so that should pretty much do it. Let's briefly have a look at why this is breaking and not starting up. We'll simply put a breakpoint over here. We also need to add this in terms of validation rules because it's currently not going to allow us to add that on if the validator is not, if we don't add in the validation for the move type. So let's just have a look at where that is. Move validation. So here we see there's a bunch of different types. So we'll just add in chess type of type queen because we've just implemented that. Let's just move these to the next line. Okay, so now we have both the implementation, we also have the implementation for the queen. So that should pass, and then let's just set a breakpoint on here to see why we are unable to move that specific piece. Okay, so now if we, for example, want to move here, now this is, okay, so we get the source, we get the destination. So the source is where we're moving from, the item that we selected the first time, and then the destination. So we can see the destination is empty, the source has the queen on it, as we can see, type queen, this is the image, that's the ID, and then we'll have a look over here, move request. So we can see the two piece here is null, the front piece is the queen that we moved. We attempt to move the piece, we get the board tile selected, we try to validate the move. The validator will say, okay, we're creating a new validator, it is a valid move, and there's no message for us, it's a valid move. And then we try to see whether the tile is available where we want to go. It is available, and we try to see if the king is in danger, and currently the king is not in danger, so that's fine. So then we come into here and we try to say, okay, where's the selected piece? The selected piece has 17 moves available between where all the places it can go. We set that piece as moved, we set the tile, we clear the pieces, we switch the players, we check whether the king is in danger, and this is where it fails because currently there is no king. So let's go in here and then fix this. So over here, this is most likely where we're going to have one. So here we're most likely getting a failure because this is first, it first tries to check this instead of first the default, and then simply what we need to do here is, if it's null, we simply return no danger because we know that the king is not in danger as a whole. So if we do a stop and restart now, the functionality should in theory allow us to continue with the rest of the stuff. So this error is happening because we're only having certain pieces running. So we can see, for example, we can move here, continue. Yeah, so now we can see the implementation of the queen works. The queen can, for example, move in horizontals, and they can move in, they can capture as well. Okay, so this is the power of using interfaces and using inheritance to be able to explicitly implement very complex code with a relatively easily reusable instance where we can now go and extend the functionality and make it really easy to use. So yeah, I hope you guys enjoyed the session. I'm gonna upload all the code up into the solution. The focus of this was more just around showing how the actual functionality could work if we wanted to implement something like this. I'm not going to spend too much time going into the specifics of the underlying solution for all of the other pieces. We will gradually implement each of them. The most important is the bishop. The bishop, like we said, moves in diagonals and it keeps on checking each square in a diagonal fashion. The same goes for a rook, and the queen is just a combination of the two. The king is a bit more complex, so there's some specifics in here that I'll briefly touch on, just to keep this relatively short and more straightforward, because the focus is on interfaces more than it is on chess as a whole. But here, for example, we have the possible moves. Again, all of them is very similar. We first handle the checks, and then we decide what squares they can move up. So a king can move up in any of the four squares around it, as well as the diagonals. So then we check for the opponent color. We go through each of the moves. Again, we look at the concept of a file. We look at the concept of a rank, and again we'll check whether there is a available move in that position. So as long as there is an available position, we'll loop through each of the possible directions that we can make. This actually should be called directions rather than moves. So here we have directions. So we look at each of the directions, and then we add the direction change on here, and then we'll go through each of the instances. We'll check whether the move is valid. If it is valid, then we'll add a new position for it, and then we will just go and add in that specific position as a string rather than individual values. And then we'll go through each of the directions like what we've added in here: one square up, one square down, one square left, one square right, diagonal, top, left. So it's basically around the king as a whole. So if this was an example, it would basically look at all of these squares around. So one left, one right, up, down, left, right, bottom left, bottom right, top right, top left. So that's what that specific functionality simply does. We'll check whether it's valid, add that to the valid moves, and in that way we're able to determine what specific pieces where it can move to in terms of squares. Here we'll have a look at what check is. So check is if a king, for example, if we refer to the readme with a king, let's see, so king moves exactly in one square in any direction, the most important of the game, and if the king is lost, it's in checkmate, threatened with a capture, there's no way to escape. Some of the other rules have been added in, like stalemate, for example. If a king has no other places to move, it will be stalemate if it's not in check. In check is when it's threatened by, if it's an enemy square or if an enemy position is looking at it. So yeah, we go and say, okay, go through each of the squares where it's not occupied and the color is not here. And we can go and upgrade this again by simply doing something. So we implemented additional items in here, so we can look at the opponent color and then we can get the opponent's pieces. Instead of trying to use this, we can just use the get pieces by this, and then we can simply go and say what are the opponent's positions. So this makes it a bit easier to read. So here we go and check each of the positions pieces, we loop through each of them, and then we get the piece, we get all of the possible moves that they can make, and we check whether any of those moves is equal to the destination moves. So in other words, if where the king is in right now is a part of any of the opponent's possible moves. And then if it is, then the king is in check. Otherwise, the king is not in check. Checkmate works very similarly. So it's in essence looking at the same instance again, where we do check if it's first in checked, and then we get all the possible moves it can make. We get the opponent. We check if any of the king's moves that he has is controlled by an opponent. For example, if it's white, we get all of the black pieces, and then we see if the available pieces, moves that a king can make, is controlled by a black piece. And then if he has one or more moves, he can escape. Otherwise, we get all of his army. So we get all of the pieces, his friendly pieces, that's not the king. And we loop through the king's army of tiles, and then we get its friendly piece. We check the friendly pieces moves, and then we go through each of the friendly pieces moves, and we create a copy of the board so that we can evaluate whether if the move that that piece will make will save the king. So here we get the source tile, we get the destination tile of where they intend to make the move, if one of those, for each of these moves that they have, and we see whether that, if setting that on the temporary board and clearing the source, so basically moving to that specific place, will uncheck the king. So for example, if it guards the king by moving to that position, we know that it's not in checkmate yet. If it goes through all of the king's armies and checks all of his friendly players' moves or pieces moves, and none of them are able to save him, then we know that it's checkmate. So let's do a brief example of this where we put the king on the board. Um, this should be an example of this already. Let's just start this up quickly. Okay, so here for example we have a black king and we have white pieces. So here if we move here, black is playing, he only has one direction, he can't move here because it's a square that's threatened by the rook. It's controlled by the rook. It can only move this way or this way. So when we move over here, it's checkmate. We can now see the game is over, and yeah, black lost. So this is like a good example of how we can go about using interfaces to treat the game and the pieces in a very common way, and be able to reuse the code in different instances, and also have a way that we can have a common object that actually has different functionality. And it also allows us to be able to implement specifics, like for example in the king has additional functionality like check, like checkmate. Again, with stalemate is very similar to checkmate as well. And this is really the power of why we use interfaces. We'll also have a look at dependency injection later on within the module that extends interfaces to automatically register them, so that we don't necessarily have to new up a new instance every time. So if we, for example, have a look at, let's say, the board, where the board is being used, with dependency injection, we no longer need to return a new instance of the board. The middleware will actually handle this. So here, for example, we have an I board, but we still have to new up a new instance of this every time. Later in the course, we'll have a look at dependency injection and see how we can make this a little bit cleaner to use and a little bit easier to understand. So yeah, that's it for this specific practical. I'm excited for the rest of the module, and I hope you guys have learned a lot. I am going to push this, all the changes that we've done, onto the answers. Please do have a look at all of the tests for this, the practice tests, or the different stuff in here. It will be very, very useful for you guys. In addition to that, I also did notice some of the exercise tests for OOP is missing. I will add this to the OOP branch questions and answers as well, and have a look at this with both of the tests in the next module that we have a look at on how we can go about implementing those in the practical. Thank you guys so much for attending and spending your time on learning and becoming better. It's been a great pleasure, and I appreciate you guys. Cheers.